Hello, in this lecture we will find out the size of line segment AE. In the drawing we have square ABCD. We know that line segment DE equals to 8 units, line segment BE equals to 2 units, and we want to find out the value of AE, or the size of line segment AE. So we want to find out the size of line segment AE. The line in the red color. So first of all, we will join together points B and D by a straight line. It is given us in the question that angle BED, this angle is a right angle, therefore triangle BED is a right triangle, so I will write it down. The triangle BED is a right triangle. And we will implement the Pythagoras theorem in the right triangle, triangle BED. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in our triangle BED, the right triangle BED, the square of the hypotenuse is DB square, and it equals to the sum of the squares of the perpendiculars. It equals to BE square plus DE square. I will repeat again. In the right triangle BED, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DB square equals to BE square plus DE square. Okay, so BD square equals to DB square equals to BE square. BE equals to 2 units, so BE square is 2 square, 2 square is 4, plus DE square. DE equals to 8 units, so DE square is 8 square, and 8 square is 64. So in total we got that DB square equals to 4 plus 64. 4 plus 64 is 68. So I write it down that DB square equals to 68. Here we take a root out of equation number 1, and we get that dB equals to the square root of 68. So we actually found out that dB, that is actually also the diagonal of square ABCD, equals to the root of 68 units. Okay, and we also know that all the angles inside the square are right angles. Therefore, angle BAD equals to 90 degrees. It is a right angle, and angle BCD also equals to 90 degrees. It is one angle out of four angles of square ABCD, therefore it is a right angle. And in the next step I will present to you a new rule, rule number 1. According to rule number 1, the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. So I will read rule number 1 again. Rule number 1 states that the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. So actually, according to rule number 1, we have in this drawing we have the diagonal DB, and according to rule number 1, this diagonal DB bisects angle ADC, this angle, into 45 degrees, so this angle will be equal to 45 degrees, and this angle also will be equal to 45 degrees. In total, they are equal to 90 degrees, and this angle also will be equal to 45 degrees according to rule number 1. And this angle also will be equal to 45 degrees according to rule number 1, because of the fact that the diagonal BD bisects the angle of a square into angles of 45 degrees. So we have 4 angles that equals to 45 degrees according to rule number 1. And if we draw the second diagonal AC, we will have another 4 angles on the other side. So we know that triangle BCD is a right angle because of the fact that this angle equals to 90 degrees. So triangle BCD is a right triangle. Okay, this triangle BCD is a right triangle. Therefore, cosinus, we will define side DC as y, that is to say DC equals to y units in its size. And we know that in the right triangle BCD, cosinus 45 degrees equals to DC over dB. DC over dB. I'll repeat again. In the right triangle DBC, cosinus 45 degrees equals to DC over dB. But according to our definition, DC equals to Y, and we have already found out that dB equals to square root of 68. So we actually found out that cosinus 45 degrees, according to equation number 2, cosinus 45 degrees in the right triangle BCD equals to Y over square root of 68. I will repeat again. In the right triangle BCD, cosinus 45 degrees equals to Y over square root of 68. We know that square root of 68 equals to square root of 2 over 2. So I will write it down. Cosinus 45 degrees equals to square root of 2 over 2. And it equals to Y over square root of 68. Here we will multiply equation number 2 by square root of 68. And we will get that square root of 2 over 2 times square root of 68 equals to Y. We know that 68 equals to 32 times 2, so I write it down. We'll substitute 68 by 32 times 2. So square root of 2 over 2 equals to square root of 32 times 2. And it equals to Y. Okay? Actually, we have a rule that states that square root of A times B equals to square root of A times square root of B. Okay, square root of A times B equals to square root of A times square root of B. So according to this rule, square root of 32 times 2 will be equal to square root of 32 times square root of 2. I will repeat again. Square root of 32 times 2 will be equal to square root of 32 times 2 according to this rule, and it equals to Y. So we have also square root of 2 over 2. So in total we got this expression here. Square root of 2 times square root of 2 is 2, so I will write it down. So we found out that 2 over 2 times square root of 32, actually it is, I made a mistake because 68 equals to square root of 34 times 2, So here we have 34. It is not 32 but 34 because 34 times 2 is 68. Okay, so here 2 over 2 is 1, so 2 will get cancelled. That what is left after we cancel 2 over 2, what is left is that we found out that y equals to square root of 34 units. So actually all the sides of square ABCD are equal to square root of 34 units. Okay? So here y equals to square root of 34, and all the other sides of square ABCD equals to square root of 34 because all the sides of a square are equal to each other. BC will be also equal to square root of 34 units, and AB will be also equal to square root of 34 units, and AD will be also equal to square root of 34 units. Okay, because of the fact that all the sides of a square are equal to each other. So in the next step I will present to you a new rule, rule number 2, and we will implement rule number 2 in our drawing. According to rule number 2, a line segment AB that subtends two equal angles or we can also say that if a line segment AB subtends two equal angles, on the same side, then the quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. I will read rule number 2 again. According to rule number 2, if a line segment AB subtends two equal angles on the same side, then the quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C and D lie on that circle. Okay, so what is the meaning of rule number 2? The meaning of rule number 2 is that if we have line segment AB so we have line segment AB this is line segment AB and this line segment AB subtends two equal angles. For the first angle is actually angle ACB that equals to theta. So angle ACB that equals to theta subtends on line segment AB. And we also have a second angle that subtends on line segment AB. Actually, angle ADB that also equals to theta subtends on the same line segment AB. Okay, so we have line segment AB, this line segment, and we also have two equal angles that subtend on the line segment AB. So if this is the reality, then according to rule number 2, the quadrilateral ABCD, this quadrilateral ABCD, this quadrilateral is inscribed by a circle. So quadrilateral ABCD is inscribed by a circle. Again, quadrilateral A, B, C, D. This quadrilateral is inscribed by a circle. As you can see from the drawing, quadrilateral ABCD is described by this black circle, and the 4 points A, B, C, and D lie on this black circle. Okay, so if we have, and this is true according to rule number 2. I will repeat again, if we have line segment AB and on line segment AB we have two equal angles that subtend on that line segment, on this line segment, or those two angles rest on line segment AB. So if this is the reality, then according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by a circle, and the 4 points A, B, C, and D lie on this black circle. Okay, so this is the meaning of rule number 2. Now we will implement rule number 2 in our drawing. In our drawing, we have two equal angles, angle DAB and angle DEB. They are both equal to 90 degrees, and they are both subtend on line segment DB. So I will write it down. So angle DAB, this angle that equals to 90 degrees, subtends on line segment DB. Okay, angle DAB, this angle that equals to 90 degrees, subtend on line segment DB. And we also have angle DEB that also equals to 90 degrees. Angle DEB that also equals to 90 degrees according to what is given us the question, also subtends on line segment BD. Angle DEB equals to 90 degrees according to what is given us in the question, and angle DEB also subtend on line segment DB. Therefore, according to rule number 2, Therefore, according to rule number 2, the quadrilateral AEBD, the quadrilateral in the green color, quadrilateral AEBD, the quadrilateral that I paint in the green color, quadrilateral AEBD, is inscribed by a circle. Quadrilateral AEBD is inscribed, so in the in the green color, is inscribed by a circle. And the 4 points A, E, B, and D lie on that circle. So I will repeat again. We have those two angles that are both right angles, they are equal to 90 degrees, and they are both subtend on segment line DB or BD. Therefore, according to rule number 2, the quadrilateral AEBD in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. This is true according to rule number 2. Okay, so actually we have quadrilateral AEBD. This is inscribed by a circle. So we have quadrilateral AEBD that it is inscribed by a circle. So according to rule number 2, the quadrilateral in the green color, quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. As you can see, those 4 points indeed lie on this blue circle. This is true according to rule number 2. So we received this drawing according to rule number 2. Okay, and actually this also is true because of the fact that we have two right angles that subtend on the same segment line BD. Okay. So I will repeat again on rule number 2. Because of the fact that we have two right angles, those two right angles subtend on the same segment line BD. Therefore, according to rule number 2, the quadrilateral in the green color, quadrilateral AEBD, is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay? So actually, this drawing is the implementation of rule number 2 in our circle, in our drawing. Okay? The implementation of rule number 2 in our drawing gives us this specific drawing. Okay? And actually, DE is one diagonal of quadrilateral AEBD, and DE also has a second diagonal. The second diagonal of quadrilateral AEBD is the diagonal AB. Okay, and I will present to you rule number 3, and we will implement rule number 3 in our drawing, this drawing. According to rule number 3, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So I repeat on rule number 3 again. Rule number 3 says that if quadrilateral ABCD is inscribed by a circle, then the products of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have quadrilateral ABCD, it is inscribed by a circle, so as you can see from the drawing, this quadrilateral ABCD is described by this blue circle. We will define the size of side AB of quadrilateral ABCD as A, it equals to A units in its size. The size of side BC of quadrilateral ABCD is B, and we will define the size of side CD of quadrilateral ABCD as C, and we will define the size of side AD of quadrilateral ABCD as D. Then we actually have two diagonals to quadrilateral ABCD. The first diagonal of quadrilateral ABCD is actually AC, and we will define the size of AC as X, that is to say X equal S, that is to say AC equals to X units in its size, and we define also quadrilateral ABCD as a second diagonal. The second diagonal is diagonal BD, and we define the size of diagonal BD is y, that is to say diagonal BD equals to 1 unit in its size. So here we have diagonal ABCD in the red color, it is inscribed by this blue circle. Therefore, according to rule number 3, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD is two pairs of opposite sides. The first pair of opposite sides, it is actually side BC is opposite to side AD, and the product of the opposite sides, it is actually B times D, and the quadrilateral ABCD has also a second pair of opposite sides. Side AB is opposite to side CD, and the product of those opposite sides, it is actually A times C, and the sum of the products of the two opposite sides, it is actually BD plus AC, and it equals, according to rule number 3, to the products of its diagonals. Okay, XY. Okay, so we'll actually implement rule number 3 in our drawing. So we will implement rule number 3 in our drawing. I repeat again on rule number 3. If we have quadrilateral, any quadrilateral that it is inscribed by a circle, like in this drawing, then the product of the quadrilateral's diagonals, in this case is x times y, equals to the sum of the products of its opposite sides. And the first product of its opposite sides, it is actually B times D, and the second product of its opposite sides is A times C, and the sum of the product of its opposite sides, it is actually B times D, it is the first product, plus A times C, that is the second product. So the sum of the product, I will repeat again, it equals to B times D plus A times C, and this product, this sum of the products, equals to the sum of the products of its diagonals, that is actually x times y, or x times y, that is the product of its diagonals, equals to the sum of the products of its opposite sides, that is actually BD times BD plus AC. Okay, so now we will implement rule number 3 in our drawing. So we have, this is our drawing, and first of all we will check if we can implement rule number 3 in our drawing. Actually, we can implement rule number 3 in our drawing, because in our drawing we have quadrilateral that is inscribed by a circle. Whenever you have quadrilateral that is inscribed by a circle, then you can implement rule number 3 in this drawing. So here we have this blue quadrilateral that is inscribed by, we have this quadrilateral, and the green color that is inscribed by this plus circle. Therefore, we can implement rule number 3 in our drawing, and according to rule number 3, the product of the quadrilateral diagonals, it is actually AB times DE. So the product of its diagonals equals to the sum of the squares of its opposite sides. Again, we have, you know that side AE is opposite to side DB, and so therefore the product of those two opposite sides, it is actually AE times DB. And the second product of the opposite sides in quadrilateral AEBD, it is actually AD is located in the opposite sides of EB. And the product of those two opposite sides, it is actually AD plus times EB. AD times EB. Okay, so I repeat again, we implemented rule number 3 in our drawing. First of all, I repeat again that we can implement rule number 3 in our drawing, because in our drawing we have quadrilateral that is inscribed by a circle. Whenever you have a quadrilateral that is inscribed by a circle, then you can use rule number 3 in that drawing. Okay, and according to rule number 3, the product of the quadrilateral diagonals, it is actually AB times DE, AB times DE, and that product equals to the sum of the products of its opposite sides. The first sum of product of the first product of the opposite sides is AE times DB, AE times DB, and the second product of its opposite sides is AD times EB, and the sum of the products of its opposite sides, it is actually those two products together. If we add them together, we will receive the sum of the products of its opposite sides. So the sum of the products of its opposite sides is AE times DB plus AD times AB. Okay, so this equality, equation number 3 is true. Equation number 3 actually, it is the implementation of rule number 3 in our drawing. Okay. So now the only thing that is left to do is to put the data inside the equation number 3, and we will get that AB, what is the size of AB? The size of AB it is actually the size of AB is square root of 34. So it is square root of 34. And AB times DE. AB times DE. DE and DE equals to 8 units according to what is given us in the question. So it is square root of 34 times 8, and it equals to AE. AE is the missing line segment, the red color. So we leave it as it is. That is the line segment that we are looking for, times DB. dB equals to square root of 68 plus AD equals to square root of 34 times EB. EB equals to 2 units according to what is given us the question. So actually we get this equation number 3 after we put the data inside the question number 3. We got this equation, this expression. So here we know that 68 is 34 times 2, so we write it down. We get that square root of 34 times 8 equals to AE instead of 64 we can write down 34 times 2 plus square root of 34 times 2. So here we will divide the equation number 3 by square root of 34 and we will get that 8 equals to square root of 2 times AE equals to square root of 2 times AE, and we have also 2. Actually here we cancelled square root of 34 because we divided equation number 3 by square root of 34, so 34 get cancelled. So here we will subtract 2 from equation number 3 and we will get that 6 equals to square root of 2 times AE. We will divide equation number 3 by square root of 2. We know that 6 equals to 3 times 2. So 6 equals to 3 times 2, so 3 times 2 square root of 2 so AE equals to 3 times 2 over square root of 2. Here we will multiply this side of the equality by square root of 2 and then we will divide it by square root of 2 and we will get that AE equals to 3 times 2 over square root of 2 so we will divide this expression by square root of 2, and then we will multiply it by square root of 2, so we change nothing. Here square root of 2 times square root of 2 is 2, so in the denominator we have only 2. AE will be equal to 3 times 2 times square root of 2 over 2. Two over 2 is 1, so in total those 2 will get cancelled. And we found out that AE equals to 3 times root 2 units, or in terms of numbers, AE equals to 4.243 units. So I will repeat again. We found out that the missing line segment AE equals to either 3 times square root of 2, or in terms of numbers, AE equals to 4.24 units. AE equals to 4.243 units. Okay, and that is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the size of line segment AE. And we know that this angle DEB equals to 90 degrees, line segment EB equals to 2 units, line segment DE equals to 8 units, and we want to find out the size of line segment AE. So we connected together points D and B by a straight line. So actually triangle EBD is a right angle. The triangle BD is a right angle, therefore we can implement the Pythagoras theorem in the right angle triangle BED. So the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and we will get that BD square equals to BE square plus DE square. So BD square equals to BE square, BE equals to 2, and BE square equals to 2 squared, that is 4. And we have also DE square. DE equals to 8, so 8 squared is 64. So in total we got that DB square equals to 4 plus 64. 4 plus 64 is 68, so we got that DB square equals to 68, and DB equals to the root of 68 units, okay? Again, we found out we have this quadratic, we have this according to Pythagoras theorem, dB square equals to BE square plus DE square. db square equals to bx square is 4d square is 64, and 4 plus 64 is 68, so we got that db square equals to 68. We took out of this equality and we found out that db equals to square root of 68. Okay. Then I presented to you rule number 1. According to rule number 1, the diagonals of a square bisect or cross the angles of the square into 45 degrees. Okay. Okay, so according to rule number 1, the diagonals of a square bisect the angles of the square into 45 degrees. We have diagonal DB of square ABCD. According to rule number 1, the diagonal DB bisects the angles of square ABCD into angles of 45 degrees. That is to say, the diagonal DB bisects the angles that equals to 90 degrees, so this angle will be equal to 45 degrees and this angle will be equal to 45 degrees, and also here this angle will be equal to 45 degrees and this angle also will be equal to 45 degrees. So this angle is a right angle, therefore triangle DBC is a right angle, and the right angle DBC, we know that cosinus 45 degrees equals to this DC over BD. Okay, and we define DC as y, so it equals to y over square root of 68. dB equals to square root of 68. So we found out that cosinus 35 degrees equals to y over square root of 68. We know that cosinus 45 degrees equals to square root of 2 over 2. Okay, and all equals to y over square root of 68. We multiplied equation number 2 by square root of 68 and we got that square root of 2 over 2 times square root of 68 equals to y. And then we know that 68 is 34 times 2, so we can write down that actually, here I made a mistake. 34 times 2 is 68. Okay, 34 times 2 is 68. So square root of 2 times 2 times square root of 44 times 2 equals to y. Okay, and here we have the rule that square root of a times b equals to square root of a times square root of b, so we can divide the root of 34 times 2 to 2 separate roots, and the root of 34 times 2 will be equal to the root of 34 times root 2, and all multiplied with square root of 2, it equals to y. Okay, so here we know that square root of 2 times square root of 2 is 2, so we got here 2 times square root of 34 over 2 equals to y, 2 over 2 is 1, so we found out that y equals to square root of 34 units. Okay, so all the sides of square ABCD are equal to square root of 34 units, and I presented to you also rule number 2. According to rule number 2, if a line segment AB subtends two equal angles on the same side, then the quadrilateral ABCD is inscribed by a circle and is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. Okay, so what is the meaning of rule number 2? The meaning of rule number 2 is that if we have line segment AB, this line segment, we have only line segment AB without the circle, and we have two equal angles that subtend on this line segment AB. Okay? So according to rule number 2, because of the fact that we have two equal angles that subtend on the same line segment AB, according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by this black circle, and the 4 points A, B, C, and D lie on that black circle. Okay? So we can implement rule number 2 in our drawing, because in our drawing we have two right angles. Those two right angles subtend on the same segment line DB. Okay, angle ABD equals to 90 degrees, and it subtends on line segment DB, and also angle DEB equals to 90 degrees, and it also subtends on the same segment line. Okay, so therefore, according to rule number 2, the quadrilateral ABED in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. Okay? So we implemented rule number 2 in our circle, in our drawing, because of the fact that we have those two right angles that subtend on the same segment line BD. Therefore, the quadrilateral in the green color, quadrilateral AEBD, is described by this blue circle, and the 4 points A, B, C, and D, A, B, O, and E lie on this blue circle. Okay, because of the fact that we have two equal angles that subtend on the same segment line DB, therefore the blue quadrilateral is described by a circle, the 4 points A, E, B, and D lie on this blue circle. Okay, so that was the implementation of rule number 2 in our drawing, but we have also rule number 3. And first of all, we can use rule number 3 here because we have quadrilateral that is described by a circle. And according to rule number 3, if we have quadrilateral that is described by a circle, then the product of its diagonals, it is actually AB times DE, and the product of its diagonals equals to the sum of the products of its opposite sides, and the sum of the products, the product of his opposite sides, or the sum of the products of his opposite sides. The first product is AE times BD, and the second product is BE times AD. And okay, So first of all, I will show you again all number 3. In all of number 3 it states that if you have quadrilateral ABCD that is inscribed by a circle, then the product of its diagonals, that is to say x times y, equals to the sum of the product of its opposite sides, and the sum of the product of its opposite sides is BD plus AC, or XY equals to BD plus AC. Okay, then we implemented rule number 3 in our drawing, and so the implementation of rule number 3 in our drawing is that if we have quadrilateral AEBD, it is inscribed by a circle. The green quadrilateral AEBD is inscribed by this blue circle. Therefore, according to rule number 3, the product of its diagonals, that is to say AB times DE, equals to the sum of the products of its opposite sides, equals to AE times DB plus AD times AB. Okay, so I will repeat again. We implemented rule number 3 in our drawing, and the implementation of rule number 3 in our drawing means that the product of its diagonals, it is actually the product of its diagonals, it is actually AB times DE, and the product of its diagonals equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides, it is actually AE times DB plus AD times AB. Okay, I will repeat again on all number 3. We have quadrilateral AEBD in the green color that is described by a circle. Therefore, according to rule number 3, the product of its diagonals, that is to say AB times DE, equals to the sum of the products of its opposite sides. The first sum of the products of its opposite sides is AE times DB, and the second the second product of its opposite sides is AD times AB. Okay, so equation number 3 is the implementation of rule number 3 in our drawing. We have the blue quadrilateral that is described, we have the green quadrilateral that is described by this blue circle. Therefore, we can implement rule number 3 in this drawing. According to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE. AB times DE. And this product of his diagonals equals to the sum of the products of his opposite sides. The first sum of the product of his opposite sides is AE times DB. AE times DB, and the second product of his opposite sides is AD times EB. AD times EB, and the sum of the products of his opposite sides is AE times DB plus AD times EB. Okay? I'll repeat again. Equation number 3 is the implementation of rule number 3 in our drawing. And we can implement rule number 3 in this drawing because we have quadrilateral that is inscribed by a circle. Whenever we have a quadrilateral that is inscribed by a circle, we can implement rule number 3 in that drawing. Okay? But here we know that AB equals to square root of 34, DE equals to 8 units, AE is the missing line segment, DB equals to square root of 68, AD equals to square root of 34, and EB equals to 2. We know that 68 is 34 times 2, so we substituted 68 by 34 times 2, and then we divided equation number 3 by square root of 34, and after we divided equation number 3 by square root of 34, what is left is actually 8 equals to square root of 2 times AE plus 2. We subtracted 2 from equation number 3 and we got that 8 minus 2 is 6. 6 equals to square root of 2 times AE. Then we divided equation number 3 by square root of 2 and we got that the size of line segment AE is 6 over square root of 2. We know that 6 equals to 3 times 2. So 3 times 2 over square root of 2 equals to AE. Then we multiplied the equation number 3 by square root of 2 and then we divided by square root of 2. Only this side of the equation we multiplied by square root of 2 and we divided by square root of 2, and we got that here we have square root of 2 times square root of 2 equals to 2, and so we have in total we got that 3 times 2 over 2 times square root of 2 equals to AE. So 2 over 2 is 1, and we found out that line segment AE that we are looking for equals to either 3 times square root of 2 units, or in terms of numbers, line segment AE equals to 4.243 units. Okay? So I will repeat again. This line segment in the red color equals to either 3 times square root of 2 units, or in terms of numbers, it equals to 4.243 units. Okay? Thank you very much.